The title of our experiment is Salt, Sand, and Solubility.
Our abstract is, have you ever mixed salt and sand together? When you look at the mixture, you can see all the tiny crystals mixed together. But what if you had to separate them out again? Do you have nightmares of tiny tweezers, a magnifying glass, and hours spent picking grains of salt and sand apart? Don't be afraid, there is another way. Using the differences in solubility between salt and sand, you can find out the simple solution to the problem. All you need is 2 glass jars, water, an oven, and the help of evaporation.
Our problem was, will different types of salt have issues dissolving and not separate right?
Our hypothesis is if we start with 100 grams of salt and 100 grams of sand, we should still end up with 100 grams of salt and 100 grams of sand after the experiment.
The materials that were used during the experiment was 100 grams of salt, 100 grams of sand, a tea kettle, 2 small glass jars with lids, water, a measuring cup, a funnel, a coffee filter, magnifying lens, and a weigh scale.
Background: when a substance is able to be dissolved in water, it is known as solubility. A homogeneous mixture is also called a solution. A mixture is a solution which can be separated and is heterogeneous. A crystal is a solid body having a characteristic internal structure and enclosed by symmetrically arranged plane surfaces, intersecting at definite and characteristic angles. The process of a liquid turning into a gas is known as evaporation.
The procedure is step 1, examine your salt and sand closely and make some initial observations. Place some salt and sand on a napkin and using your magnifying glass, make some observations. Record your observations in a data table.
Step 2, in the glass jar add 100 grams of salt and 100 grams of sand.
Step 3, put the lid on the jar and shake until the salt and sand are completely mixed together.
Step 4, using the magnifying lens, look closely at the mixture. Can you still see the individual grains of salt and sand? Record your observations in the data table.
Put the tea kettle on the stove and heat up some boiling water for step 5.
Step 6, pour a half cup boiling water into the jar with salt and sand mixture.
Step 7, using the magnifying lens, look closely at the solution. Can you still see the individual grains of salt and sand? Record your observations in the data table.
Step 8, place the coffee filter in the funnel and place the funnel on top of the second glass jar to make your separation apparatus.
Step 9, slowly pour the solution over the filter, being careful not to pour too much at once. Let the solution collect in the filter.
Step 10, look closely at the coffee filter. What do you see? Carefully scrape off any particles with a spoon and place them into the first glass jar.
Step 11, place both glass jars onto a cookie sheet and bake in the oven at 350 degrees until all of the water has evaporated from both of the jars. Watch closely.
Step 12, remove the jars and allow them to cool to room temperature before handling. They will be very hot.
After the jars are cooled, use your magnifying lens to make observations of the 2 jars. Can you still see the individual grains of salt and sand? Are they mixed together or separated? Record your observations in your data table.
Step 14, now carefully use the scale to measure the amount of salt and sand you ended up with. Do these amounts match the amounts you started with? Why do you think this happened?
In our data table, we put salt and sand at the top, and our sides as observations before mixing, amount before mixing, observations of mixture, total amount of mixture, observations after adding water, observations after separation and drying, amount after separation and drying, and then we put for the filter as whole separate column.
For analysis, as you can see from the data table, there are not any trends, and the salt and sand have almost nothing in common. At the start of the experiment, there was 100 grams of salt and 100 grams of sand. After the experiment, there was only 10 grams of salt and 160 grams of sand in total. it lost 30 grams of the mixture, and when it was done and the sand was hard and the salt was moldable and clay-like.
Conclusion. We rejected our original hypothesis because if we start with 100 grams of salt and 100 grams of sand, we should still end up with 100 grams of salt and 100 grams of sand after the experiment. But we ended up with less salt than what we started with.
Limitations: some mixture spills when trying to separate the mixture. It takes an hour and a half to evaporate at 350 degrees in the oven. And some of it can condense back into the mixture when it evaporates. Some improvements that could be made to the experiment are being more careful not to spill the mixture, use funnels. Another improvement could be to leave it in the oven longer and make sure it completely evaporates. New hypothesis: if we try to separate a mixture of sand and salt, then we will end up with less salt than sand when it is finished.
The end.